Assalamu alaikum everyone. क्या हाल है आप लोगों के? मोमेंटम मैं इंशाल्लाह करवाऊंगा. सो नेक्स्ट स्ट्रीम विल बी वर्क एनर्जी पावर एंड देन आफ्टर दैट मोमेंटम. ठीक है. सो कल देखते हैं. आज अगर हमने इसको कंप्लीट कर लिया सो वी विल डू वर्क एनर्जी पावर टुमारो. अदरवाइज विल डू अ राउंड 2 ऑफ दिस. बट आई विल डू वर्क एनर्जी पावर एंड मोमेंटम बोथ इंशाल्लाह बिफोर द एग्जाम वन वे और द अदर. सो या चलें. Let's not resolving forces, but I've already done. Mock inshallah tomorrow. Tomorrow most likely at 8 p.m. I'm going to be taking an M1 mock. ठीक है. अच्छा बेटा, I'm not here to talk about leaks. I think we've had plenty of discussion about leaks already. ठीक है. There's nothing that we haven't discussed. As far as what ifs are concerned, the list of what ifs is an endless list, so we're not going to dive into that. ठीक है. Let's focus on what is in front of us and let's pay attention to that. ठीक है. So I hope that's clear. Now let's begin. Achha, we're doing pulley. The kind of questions that we're going to solve in pulley, we're going to start from the most common ones. ठीक है, जिसमें you have two particles that are hanging vertically, and then we are going to solve other questions also where you have one that is on an inclined plane, one that is such that one is hanging vertically, one is on an inclined plane, both are on an inclined plane. That's the kind of questions inshallah we're going to cover. My O-level notes are on the website, or what you can do is you can watch the syllabus run through wali stream in which I've shared my notes as well. How long will this stream be? I don't know, but it's going to be a while. Okay, so don't expect this to be a short stream. It's going to take a while. Okay, probably 10 तक तो होगी इंशाल्लाह. ठीक है. अच्छा, so let's begin. Let's begin with the first type. अच्छा, the first type is when both the particles are hanging vertically. ठीक है. So I'm solving question number 24. Let's see what it says. This is a question from May-June 2021, paper 4, variant 1. Two particles A and B, masses m kg and 0.1 kg respectively, where m is greater than 0.1. Now the question is, why did they tell us that m is greater than 0.1? Question for you guys. Why did they feel the need to tell us that m is greater than 0.1? ये आप लोगों से सवाल है. क्यों बताया? Out of nowhere? For no reason? Or is there some reason behind it? Because if it's greater than 0.1, that means it's heavier than the other particle. And if it's heavier than the other particle, that means this is the direction in which it's going to move. Okay, A will move down, which means B will move up. ठीक हो गया? So always make double arrows to show the direction in which the particle is moving. Okay, now exponential growth and decay can come in P1. What do you mean P1? Beta, P1 तो आपका हो नहीं गया, and there's no need to spam beta. ठीक है. So exponential growth and decay आपका हो गया है. P1 तो आपका हो गया. Yes, it can come in P2. ठीक है, and there's no need to spam. All right, now अच्छा, let's read the question further. The string passes over a fixed smooth pulley and the particles hang vertically below it. Both particles are at a height of 0.9 meters above horizontal ground. The system is released from rest while both particles are in motion, the tension in the string is 1.5 Newton. Particle B does not reach the pulley. Find M. Okay, now, so A will come down because of its weight. What is the weight going to be? The weight is going to be 10 m, and tension, as we know, is acting away from the object. So that's tension in this direction. Now the force due to which B will move up is going to be the tension, okay, which we already know. And the force that's acting down is the 1 Newton force. So first let's look at the forces from A's perspective. So if I look at the forces from A's perspective, since A is moving down, that means the force that's acting downwards is the positive force, is the forward force. The force that's acting upwards is the backward force, equals to mass times acceleration. Now what is T? We already know that T is equals to 1.5. So 10m minus 1.5 is equals to mass times acceleration. Okay, now let's see what's next. Let's look at the forces from B's perspective. So from B's perspective, since B is moving up, that means it's moving up due to tension. Tension minus 1 is equals to 0.1A. And we already know what tension is. Tension is 1.5. So 1.5 minus 1, which basically means that it's simply going to be 0.5 equals to 0.1A. Okay. Now what is A equal to? A is equal to 5 meters per second square. Okay, but that's not the thing. We're not supposed to find out the value of A. We're actually supposed to find out the value of M. So 10m minus 1.5 equals to 5m. This means that 5m equals to 1.5, which means m is equals to 1.5 divided by 5. What's that equal to? 0.3, I believe. 1.5 divided by 5. Yep, that's equal to 0.3 kg. Okay, now find the speed at which A reaches the ground. So the speed at which A reaches the ground, let's see. The distance that it travels to reach the ground is equals to 0.9 meters. All right. The acceleration is 5 meters per second square. And the initial velocity, notice the question says that they are released from rest. That means the initial velocity is equals to 0. Okay, and what we have to do is we have to find out the time. So which equation of motion makes the most sense? This is the equation that makes the most sense. S is equals to ut plus half at square. Any other equation we can use? V equals to u plus at? No. So S is 0.9. Ut simply becomes 0 plus 1 upon 2 into 5 into t square. So let's cross multiply. 0.9 times 2 divided by 5. So t square is equals to 0.36, which means if you work out the value of t turns out to be... Achha, wait a minute. We're supposed to find out the speed. Oh, I just realized we're supposed to find out the speed. Okay. Not the time. I thought we were supposed to find out the time. Okay, my bad. I thought we were supposed to find out the time. Since we're supposed to find out the speed, then we're going to use the second formula. Yeah, I didn't realize. I thought we were supposed to find out the time. So the formula that makes the most sense is 2as equals to v square minus u square. So 2 times 5 times s, which is 0.9, equals to v square. Let's see what we get. 2 into 5 into 0.9. Let's take the square root of it. So v is equals to 3 meters per second. Yeah, we'll do so we'll do all sorts of questions, inshallah. We'll try and do all sorts of questions. If not, then we'll do another round of this, inshallah, tomorrow early morning. Okay, now let's do this. Achha guys, don't worry, I will solve all pulley related questions, inshallah. Okay, you guys can download this PDF. It has all the questions there are. Okay, the easy ones, the difficult ones, the extremely difficult ones also. Okay, so we're gonna solve all of them, don't worry. Okay, wo double pulley wale bhi karenge. Don't worry about that. But at least let's start with the basic stuff before we move on to the more complex stuff. Okay. 4B of 42. If that's a pulley related question, then yes, I can. Early morning in the sense, not like 7, 8, but most likely 11. 11ish, we'll do another round of this, and then tomorrow night, inshallah, we'll have a mock. Okay? Two particles A and B of masses 2.4 kg and 1.2 kg respectively are connected by a light, inextensible string which passes over a fixed smooth pulley. A is held at a distance of 2.1 meters above a horizontal plane and B is 1.5 meters above the plane. The particles hang vertically and are released from rest. Very important. In the subsequent motion, A reaches the plane and does not rebound, and B does not reach the pulley. Show that the tension in the string before A reaches the plane is 16 newtons and find the magnitude of the acceleration before A reaches the plane. Okay. बेटा व्हाट्स गोइंग टू देखो कैम्ब्रिज ने बोला है ना 7th को वो करेंगे अनाउंस, तो बेटा 7th तक का वेट कर लो अभी से. व्हाट इफ दिस व्हाट इफ दैट मैं अपने फजूल के सिनारियोज बना के टाइम ज़ाया करने की क्या ज़रूरत है? ठीक है, आई एम नॉट अ कैम्ब्रिज एम्प्लॉय, आई डोंट नो व्हाट दे आर गोइंग टू से, सो बेस्ट वेट एंड फाइंड आउट. ठीक है, विल दे रिफंड, विल दे, व्हाट इफ दिस गेट्स लीक, व्हाट इफ दैट गेट्स लीक? इट्स अ सिली डिबेट, ओके, सिली डिस्कशन, सो वेट एंड फाइंड आउट, सिंपल एज दैट. ठीक है, नाउ two particles A and B of masses 2.4 and 1.2. All right. So what do we know about A? We know that A is 2.1 meters above a horizontal plane and B is 1.5 meters above the plane. So that means A is higher than B. So because we have to make a rough sketch over here, make sure to keep that in mind. So this is A and this is B. ठीक हो गया? Okay. Now A is 2.1 meters. So that means this distance is 2.1. Not drawn to scale obviously, and B is 1.5, so here we go, this is 1.5 meters. ठीक है, अच्छा, then the question says okay, they're released from rest. अच्छा, which one's the heavier particle? A is the heavier particle, so that means A will move down, and the force due to which it's going to move down will be its own weight, and that is 24 Newton. So that's 24 Newton acting in this direction. Tension, as we know, always acting away from the object. B will move up, and the force that's going to act in the direction that B is moving in is going to be T. The force that's acting down will be its own weight, which is equal to 12 Newton. There we go. Okay, now let's look at the forces from A's perspective. So since A is moving down, it's moving down because of its own weight. Tension is acting in the opposite direction, equals to mass times acceleration. So that's 2.4 A. Let's look at the forces from B's perspective. So B is moving up, so that means tension minus its own weight, which is 12, equals to 1.2 A. Now let's add them up. We're supposed to show that tension equals to 16. So this gets eliminated. 2.4 minus 12 is equals to 12. And 2.4 plus 1.2, that's equal to 3.6. So A is equals to 12 divided by 3.6. That's equal to 10 upon 3. Do not round this off. So acceleration is equals to 10 upon 3 meter per second square. Now to find out T, let's use any one of the two equations. So I'm going to use the first equation. To 2.4 minus T equals to 24 into 10 upon 3. So इस acceleration की value को multiply करते हैं 2.4 से. We get 8, so we have 24 minus 8 equals to T, which means T is equals to 16. This is what we had to show, and we have done just that. So there you go. For good measure, write hence shown. ठीक हो गया. Why don't we round acceleration? Because it's the exact answer. It's not possible. देखो, why would you get acceleration as minus? When the system is released from rest, why would it decelerate? Okay, if the system is released from rest, then why would it decelerate? It will start moving, right? It will start moving, that means it's going to accelerate. So negative acceleration does not make sense. If you're getting negative, that means you probably messed up the signs maybe. But think logically. As soon as you release it from rest, the particles start moving. So if they're starting to move, that means the speed is increasing, and if the speed is increasing, that means they're accelerating. So negative acceleration does not make sense. Okay. All right. Now, so then comes part B. Wait, we're given so much space for this question. Wow. अच्छा, जिसके लिए देना चाहिए part B, उसके लिए दिया हुआ नहीं है, part A के लिए दिया हुआ. खैर. Part B says find the greatest height. अब ये questions बड़े मजे के होते हैं. Questions like these are fun to solve. Find the greatest height of B above the plane. Okay. Now let's treat this as a story. Okay, let's treat this as a story. Now this is the first part of the story. Okay, you can think of this as scene 1. Achha, what happens as soon as the system is released from rest? We know what happens as soon as the system is released from rest. As soon as the system is released from rest, we know that A, being the heavier particle, falls down, and B, being the lighter particle, will move up. अच्छा, मैं ये सारी forces अब मिटा रहा हूँ because we don't need them anymore. Okay. Now, since A falls down, B moves up. Bear in mind that A was 2.1 meters above the ground. If it falls down, that means B is now right here. ठीक है, B, the height of B has increased by 2.1 meters. Okay, because A falls 2.1 meters, that means the height of B also increases by 2.1 meters. Okay, not drawn to scale. You're not supposed to draw this to scale, but it's a good idea to make a rough sketch nonetheless. Okay, so don't waste time drawing this accurately, but a rough sketch will go a long way. Okay, will help you a lot in solving this question correctly. So this is where B is, and I'm going to call this B prime. Okay, and you can see that its height will further increase by 2.1 meters. Achha, what happens then? As soon as A hits the ground, what happens then? As soon as A hits the ground, what happens then? As soon as A hits the ground, the string will now become slack. Okay, tension is equals to 0. That's correct. That means now the string has become slack. Okay, so this is where A is, this is where B is. And as soon as the string will become slack, because B already had some velocity, okay, so because B was already moving at a certain velocity, and now that the string has become slack, it will move slightly above before it comes to rest. Okay, because the string has now become slack, it will move further up before it comes to rest. Now I'm going to call this B prime prime. Okay. So what we really have to find is the distance that it moves when the string becomes slack. Okay, what we really have to find is basically this distance, जिसको मैं x कह रहा हूँ. ठीक है? अच्छा. Before I dive into this, I'd like to make you guys read some important key points. Okay, so before I dive into this, I'd like to make you guys read some important key points. ठीक है, these ये पढ़ते हैं, and then let's apply them one by one. When two particles are suspended vertically and one hits the ground, the rope becomes slack, due to which the other will rise. Okay, due to which the other particle कर लो यहाँ पे, due to which the other particle will rise. ठीक है, we call this concept inertia. When the other particle is rising, it will be under free fall conditions since the rope is slack. Okay, which means the acceleration due to free fall will be taken as -10 or +10 depending on the direction. Okay, the speed with which one particle falls is the speed with which the other rises. Okay, so the speed with which one particle falls is the speed with which one rises. Okay, so the speed with which A hits the ground is the speed with which B rises. The time taken for the particle to rise up is equal to the time taken to fall down till the string/rope becomes taut again. So let's suppose it takes 0.2, it remains 0.2 seconds under free fall conditions on the way up. That means it will take 0.2 seconds to come back down till the string is taut again. Yeah, I'll do double pulley also. ठीक है, yeah, upward, if it's going up, that means the acceleration due to gravity is negative. ठीक है, अच्छा, I'll do double pulley also. Now, no need to spam. अच्छा, अब some important key points. The final velocity of A equals to initial velocity of B. The final velocity of A, meaning the velocity with which A hits the ground, is the initial velocity of B. Okay, under free fall conditions. Then it says the final velocity of B, that is when it reaches its maximum height when the string is slack, is equal to 0. Okay, so as soon as it reaches its maximum height while the string is slack, the final velocity is equals to 0. Achha. Then duration for which the string is slack on the way up equals to the duration for which the string is slack on the way down. So if the string remains slack for 0.2 seconds while B is going up, that means it will remain slack for 0.2 seconds on the way down. Velocity with which the particle comes down just before the string is taut again equals to the velocity with which it went up right before the string became slack. Okay, so the symmetry that we follow in kinematics, that if let's say it goes up with a speed of 5 meters per second on the way down, when it reaches the same point, the starting point, it will reach the speed of 5 meters per second also. ठीक हो गया? Okay, अब solve करते हैं इसको. I can see कि आप लोग को ज़रा आंसर्स दे रहे हैं. अच्छा, अब इसको करते हैं सॉल्व. अच्छा, हमने एक्सेलरेशन क्या निकाली थी? हमने एक्सेलरेशन निकाली थी 10/3. 3. So yeah. Now, let's find out the final velocity of A. Okay, let's focus on the final velocity of A. What is that? We don't know. What is the distance that it falls? It falls 2.1 meters. What is its initial velocity? Its initial velocity is equals to 0. What is its acceleration? Its acceleration is 10 upon 3. Okay. So with the help of this, I can find out the final velocity of A, which is basically the velocity with which it hits the ground, using which formula 2as equals to v square minus u square. So 2 into 10 upon 3 into s, which is 2.1, equals to v square minus u square, which is equal to 0. Achha, v square ko v square hi rakhna. I'll tell you why. Or at least keep it in square root form, and I'll tell you why. So v square equals to 14, which means v is equals to square root of 14. Keep this as it is. Now this is the final velocity of A, and this is now going to be the initial velocity of B. Okay. Now let's focus on B. So B has an initial velocity of under root 14 as it's going up. Okay, so as it's going up, it has an initial velocity of under root 14. When it reaches its maximum height, the final velocity is equals to 0. And during this, the acceleration due to gravity is minus 10. Why? Because the string is slack, there's no tension, so it's under free fall conditions. So the final velocity equals to 0. The distance that it falls, the distance that it rises is what we're supposed to calculate. The acceleration due to gravity is minus 10. So 2 times minus 10 times s equals to 0 squared minus under root 14, the whole thing squared. So now you can see the benefit of keeping root 14 as root 14 only. So s is equals to 14 divided by 20, which is equal to 0.7. Now, is 0.7 going to be the answer? No. If you think 0.7 is the answer, you're wrong. The greatest height, okay, so the greatest height that it reaches above the plane is the initial height, which is 1.5, then 2.1, because A falls 2.1, and then under free fall, that's 0.7. So what's that equal to? 1.5 plus 2.1 plus 0.7, oops, 1.5 plus 2.1 plus 0.7, that's equal to 4.3 meters. And there you go. That is your answer. ठीक हो गया. Okay, wow, क्या idea दिया भाई. Form an alliance with other major teachers and mathematics etc. through which you organize meeting with your school heads, convince them to leave Cambridge or for edXL. बेटा, the problem with edXL is, मैं आपको बता दूँ, Reddit पे जाओ और लिखो edXL leak. ठीक है, आप कैम्ब्रिज को भूल जाओगे. You think edXL exams don't get leaked? They get leaked. And interestingly, they don't actually get leaked here in Pakistan. They get leaked in UK also. So yeah. And the thing is, it's not that, and another thing that you need to understand is that edXL is basically under Cambridge also. So yeah. And it will be conducted by British Council only. So the only solution is a completely different board altogether, which could be, I don't know, maybe IB. I haven't looked into IB. I don't know what that's like, but something that doesn't come under Cambridge. So yeah, I hope that's clear. Now let's do another question. AQA, Oxford, ये सब Cambridge के अंदर आता है बेटा. So British Council said exams didn't get leaked here. What to do? Here in the sense, which country? So in questions related to friction, is it mandatory to form an inequality if it asks for least value, that coefficient of friction? If it's asking for the least value, then yes, you have to form an inequality, and then in the end you can give your answer as a single value. Yeah, आप कर सकते हो. Okay, let's do another question. Let's do one more question with both objects being vertical, then we'll start looking at some other question, some other type, okay? So this is question number 23. Say they get leaked all the way to Italy and Saudi. The thing is, beta, if the paper gets leaked in one city, one country, that means it's as good as leaking in the entire world. ठीक है, अब Cambridge वाले, honestly speaking, काफ़ी stupid हैं, because the last year the geniuses, I don't know who came up with that, but the genius plan that they came up with was that they're not going to count the questions that got leaked. तो अब कोई उन बेवकूफ़ों से ये पूछे कि if someone has leaked 1 or 2 questions, that means someone, the same person possibly, has pictures of the entire paper. It's just that they didn't put them up online, but they said that they're only going to cancel the 2 questions. So I don't know. I don't know what they were thinking, if they were thinking to begin with. But anyway. So let's do question number 23. Let's see what it says. 2 particles of masses 0.8 kg and 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. देखो बेटा, the thing is, I'll tell you what. The thing is, उनको पता है हमारे standards कितने low हैं. ठीक है, उनको पता है हमारे standards कितने low हैं. उनको पता है कि यार बस क्योंकि Cambridge का ठप्पा लगा हुआ है, British Council का ठप्पा लगा हुआ है, उसकी आड़ में इनको कुछ भी बेच दो, इन्होंने ख़रीद लेना. ठीक है, तो जब तक हम अपने standards खुद बेहतर नहीं करेंगे ना, तो वो लीक भी होते रहेंगे और इन्हीं चक्रों में हम फंसते रहेंगे. तो जब तक हम कोई ऐसा स्टैंड नहीं लेंगे which really hurts them, ठीक है, we're a very big market, you guys don't realize that, we're actually a very very big market for Cambridge. So for as long as we don't hit them where it hurts, they're not going to do anything about it. ठीक है, आप लोग खुद ही अंदाज़ा लगाओ, कभी एक्सपो सेंटर में बैठे हुए, if let's say you guys end up completing the paper early, so just start doing the math. How many students are there on average, how many exams they appear for, and what is the per subject fees. And then remember that you are in one center of one city. Okay, then try to figure out how many students there are, how many cities there are, how many, chalo country to chhod do, abhi to we're just talking about Pakistan. So you'll probably you won't be able to calculate. Okay, you'll run out of zeros as to how much money they make from Pakistan. So that's why they don't care. Okay. Here, anyway, 2 particles of masses 0.8 kg and 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. The system is released from rest with both particles 0.5 meters above a horizontal floor. In the subsequent motion, the 0.2 kg particle does not reach the pulley. All right. Show that the magnitude of the acceleration of the particle is 6 meters per second square and find the tension in the string. All right. So since 0.8 kg is the heavier particle, that means this is the particle that moves down. The 0.2 kg particle will move up. So always make double arrows to show the direction in which the object is moving. Okay, now the 0.8 kg particle will move down because of its weight, and tension will be acting in the opposite direction. Here is the weight, 8 Newton. Here is the weight of 2 Newton. So 8 minus t is equals to 0.8 a, and then we have t minus 2, which is equal to 0.2 a. Add the 2 equations, t gets eliminated, 8 minus 2 is equals to 6, so 6 is equals to a, and that's it. We have the value of a, 6 meter per second square directly. Okay, now then we have 8 minus t, which is equal to 0.8 a, and considering that we already have the value of a, 0.8 times 6, that's 4.8, but just to be on the safe side, let's check. Yep, that's 4.8, and t is equals to 8 minus 4.8, that's equal to 3.2 Newton. So tension bhi aa gaya hamare paas 3.2 Newtons. ठीक हो गया? Okay, now S1 beta, as soon as I'm done with P1, I guarantee you okay, I'm only going to do S1 and P3. Well, I'll do add maths also, but yeah, but I'll have enough time, and I'll have enough time inshallah to do S1 also. Yes, I know I said कि मैं S1 आज करूँगा, but I don't think I'll be able to do it considering how little of M1 I've covered. So I'd like to prioritize M1, but I will do S1 inshallah. It's my commitment कि S1 का भी पूरा syllabus before the exam I will do it. Don't worry. When is a value an exact value or very large whole numbers? No need to make it 3 significant figures then. No need to make it 3 significant figures. Okay, if it's exact, doesn't matter how many significant figures there are, make sure that you write all of them. Okay, now up greatest height of the particle, of the 0.2 kg particle above the floor. Okay, remember we're supposed to treat this as a story, okay, as an act with multiple scenes. Okay, so ये है हमारा act 1 scene 1. Okay, now scene 2 is when the heavier particle hits the ground. Okay, so scene 2 is the heavier particle has hit the ground. Okay, which means that the lighter particle, which was already 0.2 meters above the floor, will now further rise 0.5 meters above the ground, will now further rise 0.5 meters above the ground. Okay, I'm going to call the heavier particle A and I'm going to call the lighter particle B, just so that it's easy for us to refer to them. Okay, so this is now where A is, I'm going to call it A prime. And this is now where B is, I'm going to call it B prime. Then what happens is, in the third and the final scene, the string becomes slack. And as soon as the string becomes slack, what happens is that A ko to kuch nahi hoga, because it's not like it's going to go through the floor, but B will now further rise up. Okay, B will now further rise up. So I'm going to call this B prime prime. Okay. अच्छा, आप लोगों ने 1.3 निकाल लिया. That's very nice. Let's see what the correct answer is. So remember, the final velocity with which A hits the ground is what we want, because that is what's going to be the initial velocity of B. So initial velocity of A is equals to 0. The distance that it falls is 0.5. The acceleration is 6. So A is equals to 6. And what we want is the distance. What we want is the final velocity, yeah. So we're going to use 2as equals to v square minus u square. So that means 2 times 6 times 0.5 equals to v square minus 0 squared. So let's see what v square is going to be equal to. 2 times 6 times 0.5, it's just going to be 6. So that means the final velocity of A is equals to under root 6. Now the final velocity of A now becomes the initial velocity of B, which is equal to under root 6. And the final velocity of B is equals to 0. ठीक है, so string slack होगी, ये ऊपर जाएगा, इसकी final velocity 0 होगी. Initial velocity is root 6. The acceleration due to gravity, since it's going up, will be minus 10. And what we want is the distance that it travels. So we can use 2as equals to v square minus u square. So we have 2 times minus 10 into s, which is equal to 0 squared minus root 6 squared. So s is equals to 6 divided by 20, which is 0.3. अच्छा, अब I can see यहाँ पे ये debate चल रही है. The question says find the greatest height of the 0.2 kg particle above the floor. So it was already 0.5 meters above the floor. A fell 0.5 meters, which means this will now rise 0.5 meters and another 0.3 due to the string becoming slack. So altogether, its greatest height is 1.3 meters. ठीक हो गया? There we go. Okay, now let's do another type and let's do these type of questions. ठीक है? अच्छा, इसके भी मैं कुछ ज़रा latest वालों को prioritize कर लेता हूँ. चलो पहले ये वाले कर लेते हैं. So why didn't we take minus 6 as acceleration? Because we were talking about A तो नीचे आ रहा था. So why would we take it as minus 6? We were talking about A, so why would we take it as minus 6? Why can't we use 10? Because velocity is decreasing to 0. अच्छा, wait, I thought आप मुझसे सवाल पूछ रहे हैं. अच्छा, let's do some questions like these, although these are not very recent. ठीक है, तो चलो एक काम करते हैं. Let's not treat them as top priority. We'll do them type 2 को हम later. We'll do them later. Let's cover type 3 because type 3 are actually quite recent. So what is type 3? Type 3 is when you have one particle which is on an inclined plane, and the other that's hanging vertically. Okay. Now, let's have a look at question number 14. Particles A and B of masses 2.4 kg and 3.3 kg are connected by a light inextensible string that passes over a smooth pulley which is fixed to the top of a rough plane. The plane makes an angle of theta degrees with horizontal. Particle A is on the plane and the section of the string between A and the pulley is parallel to a line of greater slope. Alright, sir, on average, what score is suitable for M1 out of 50 at this point according to you? But just aim for 45 plus. Okay, now I know some papers won't allow you to do that considering how difficult they are, but if you're looking for a score to be on the safe side guaranteed, then 45 plus is good. Anyway, let's continue. The plane makes an angle of theta degrees with the horizontal. Particle A is on a plane and the section of the string between A and the pulley is parallel to a line of greater slope. Particle B hangs vertically below the pulley and is 1 meter above the ground. The coefficient of friction between the plane and A is mu. It is given that theta is equals to 30 degrees and the system is in equilibrium with A on the point of moving directly up the plane. So if A is on the point of moving directly up the plane, that means this is the direction that A is going to move in. And if this is the direction A is going to move in, that means this is the direction in which B is going to move in. Okay, now. So, let's first look at the forces one by one. So we know that, let's not ruin the actual diagram. Let's draw it separately. Okay, and that's what I would recommend, that if you are annotating on the diagram that's given, make sure you do it using a pencil, or if it's something simple, it's best that you draw it separately. Okay, so we know that B moves down because the question says so, that A is on the point of moving up the plane, so therefore B moves down. Even if the question did not mention that, we would still assume that B moves down because B is the heavier particle. Okay. So the question is, what's the force that's acting in the direction B is about to move in? That's 33. What is the force acting in the opposite direction? That is tension. Okay. So let's look at the forces from B's perspective. So from B's perspective, it's 33 minus T. There's no friction to deal with as far as B is concerned, equals to 3.3A. Okay. Now let's look at the forces from A's perspective. So the question is, what's the force due to which A is going to move up the plane? That is basically the component of the weight. No, that is basically the tension. A is going to move up the plane because of tension. Now the question is, what are all the forces that are acting in the opposite direction? So here's the weight, which is 24 Newton. This angle will be equal to 30 degrees because the question says so, that theta is 30. Okay, this will be 24 sine theta, which is acting down the plane. And this will be 24 cos theta acting perpendicular to the plane. And we have the normal reaction force from the point of contact, that's equal to R. And because A is moving up the plane and the plane is rough, that means we have to consider the frictional force acting in this direction. Okay. Now, let's see. Let's look at all the forces. Let's look at the forces from A's perspective. So the reason why it's moving up the plane is because of T. Okay. And the forces acting in the opposite direction are 24 sine theta. Now theta is 30. And another force acting in the opposite direction is frictional force. Now notice that I've written this as mass times acceleration, but in both cases, acceleration is equals to 0. Okay, so since acceleration is equals to 0, that means they're in equilibrium. So this is equal to 0 and this is equal to 0. Okay, this is also equal to 0. Now, since they're in equilibrium, that means immediately we know that T is equals to 33. Okay, immediately we know that T is equals to 33 because they're in equilibrium. Now what we can do is this: 33 minus 24 sine 30, make sure your calculator is in degree mode. So that's minus 12 minus the frictional force equals to 0. That means the frictional force is equals to 33 minus 12, which is equal to 21. But as question ke baad, we'll take a namaz break, okay? Don't worry. Now, what's the frictional force equal to? Frictional force is equals to mu times r. Now, we can't find out the value of mu for as long as we don't have r, but we can see that r is equals to 24 cos theta. That means r is equals to 24 cos 30. Let's find out the value of r. 24 cos 30, let's keep it in its exact form. So that's 12 under root 3. And we can plug it in here. So mu is equals to 21 over 12 under root 3. So that means mu is equals to 21 divided by answer. Oop, मैंने minus कर दिया. 21 divided by 12 under root 3. That's equal to 1.01036, which correct to 3 significant figures is equals to 1.01. There you go. Okay. Hence shown. Shown, yeah, prove, whatever. Okay. All right. Now let's do part B. It is given instead that that theta is 20 and mu equals to 1.01. All right. The system is released from rest with the string taut. Find the total distance traveled by A before coming to instantaneous rest. You may assume that A does not reach the pulley and B remains at rest after hitting the ground. All right. This should be fun. अच्छा बेटा सवाल पढ़ लो. सवाल में उसने बोला हुआ है correct to 3 significant figures. तो जाहिर है अब हम अपनी तो नहीं चलाएंगे ना. We'll answer the question accordingly. ठीक है. So once again, let's treat it as a story with multiple scenes. So this is scene 1. Okay, nothing happens. Then the next scene. अच्छा, how much space do we have? I'm pretty sure इसके आगे एक और page होगा. ठीक है. So in the next scene, what happens is B hits the ground. Okay, so this is the new position of B. Let's call it B prime. Okay. Now, and then A moves an equal distance that B travels up the plane. Let's call it A prime. ठीक है. अच्छा, अब एक काम करते हैं, इसी में हम दूसरा scene भी accommodate कर लेते हैं. What will happen after that? The string becomes slack. And because there must be a certain velocity with which A was traveling, so it's not going to come instantaneously at rest, just like B came. B came instantaneously at rest because it hit the ground. A, on the other hand, will not come instantaneously at rest. It will travel further up due to inertia. Okay? A will travel further up due to inertia. So, बेटा अब कोई भी leak से related मैंने discussion नजर आया, I'm afraid I'm going to have to hide you, starting with you. ठीक है. कौन सा? Sayyid Athar Mahmood. Okay. Now, अच्छा, अब let's have a look at the distance. We know that A will move 1 meter while the string is taut, but what we're supposed to do is we're supposed to find out the total distance traveled by A before coming instantaneously to rest. So how do we figure that out? Let's see. Now, let's first of all find out the final velocity of B. Okay, so we need to find out the final velocity of B. What about the initial velocity of B? The initial velocity of B is equals to 0. Okay. And, achha, wait a minute. So, यहाँ पे तो we can't consider the previous scenario. Yeah. We can't consider the previous scenario क्योंकि यहाँ पे आपका थीटा और वो सब change हो गया. ठीक है, तो कोई बात नहीं. Let's now look at the forces from B's perspective. Okay, we can't use the previous acceleration because that has changed. Because theta has changed, so everything has changed. So if I look at the forces from B's perspective, so B comes down because of its weight. So 33 minus T is equals to 3.3A. Okay. Now we don't have acceleration. Okay. We have acceleration for a different scenario. Now this is a different scenario. Okay. Now let's look at A. So if I look at forces from A's perspective, A is moving up because of the tension. The force which is acting parallel to the plane in the opposite direction is 24 sine 20. Okay, so 24 sine 20 acting in this direction. 24 cos 20 is the component which is perpendicular to the plane. Oops. And then we have the normal reaction force, R. Okay. And of course, since it's moving up the plane, that means the frictional force is going to be acting in the opposite direction. This is an 8-mark question, okay? So got to be patient here. You can't just lose your cool and rush into it. So got to be patient. ठीक है, b नीचे को आएगा, so make a double arrow to show the direction in which it's moving. Now if I look at the forces from A's perspective, so it's t minus 24 sine 20, okay, minus the frictional force, all right, equals to mass times acceleration, which means 2.4 a. All right. Now 33 minus t is equals to 3.3 a. So let's expand this. So t minus 24 sine 20, अच्छा ये plus होगा, minus the frictional force equals to 2.4 a. All right. So now if I add the two, let's see what we end up with. So I'm adding the two equations. What acceleration did you take in free fall? I haven't reached that stage yet, beta. I haven't reached that stage where I take the free fall condition. Okay? This is October-November 2023, paper 4, variant 3. So we have 33 minus 24 sine 20 minus the frictional force is equals to 3.3 plus 2.4. So 3.3 plus 2.4, that's equal to 5.7. So this is equal to 5.7 a. अभी देख लेते हैं acceleration क्या आ रही है. Hold it guys, hold it. Now let's focus on the frictional force. Frictional force we know is equals to mu times r. Now normal reaction force will simply be equal to the component of tension which is perpendicular to the plane, since there is no other force. So that's 24 cos 20. So r is equals to 24 cos 20. So the frictional force is equals to mu, which I think is 1.01. Yeah, 1.01 into 24 cos 20. So that means the frictional force equals to 1.01 into 24 cos 20. What's that equal to? That's equal to 22.778. Okay. Now, so here we are, 33 minus 24 sine 20 minus 22.778 yeah, equals to 5.7a. Let me just make sure. Yeah, okay. Now, so 33 minus 24 sine 20 minus the answer. So we're looking at 5.78 to be equal to 2.013367. And now let's find out the acceleration. So divide this by 5.7. So we finally get the acceleration, which is equal to 0.3532. 222 meter per second square. So we're not supposed to find out the acceleration. Okay, we're not supposed to find out the acceleration. Okay, now बेटा इस क्वेश्चन के बाद हम ले रहे हैं नमाज ब्रेक, सो रिलैक्स. ठीक है, आपको ज़्यादा जल्दी है आप चले जाएं, बाद में रिकॉर्डिंग देख लीजिएगा, बट वी आर गोना टेक अ नमाज ब्रेक आफ्टर दिस क्वेश्चन. ठीक है, ओके. नाउ देन लेट्स फाइंड आउट द स्पीड विथ विच B hits the ground. Okay, let's find out the speed with which B hits the ground. So the initial velocity of B is equals to 0. We have the acceleration 0.35322. Okay, not rounding it off because it's not the final answer. The distance that it falls is 1 meters. So using the formula 2as equals to V square minus U square, we can find out the speed with which B hits the ground. Achha. So I'm going to multiply this by 2, then I'll take the square root of it. So if I take the square root of it, the velocity at which B hits the ground is 0.840502 meters per second. Okay? So this is the velocity with which B hits the ground. So let me see, I'm pretty sure considering it's an 8-mark question, इसके आगे एक और पेज हमें दिया हुआ होगा. ठीक है, so let me just have a look. What if I blank out? अच्छा, इसका पहले मैं ये सवाल सॉल्व कर लूँ, फिर मैं इसका जवाब दूंगा. ठीक है. So anyway, this is what we have worked out up until now. We have worked out the speed with which B hits the ground, and now that is going to be the same speed with which A travels up the plane. ठीक है, तो अब हम इधर आ गए. The initial velocity of A is what we just worked out, 0.8405. The final velocity of A is equal to what? Is equal to 0. Acha, notice that when the string is slack, there is no force that's moving in this direction. Okay, there is no force that's acting in the direction that A is moving in. However, there are multiple forces that are acting in the opposite direction. ठीक है, A अभी भी ऊपर को move कर रहा है, but there is no force, it's moving because it has a certain velocity, but there are still forces that are acting in the opposite direction. Now the question is, what are those forces? That is its own weight component and the frictional force. Okay, because the plane is rough, so friction will remain there, and we also have its own weight component. So the force that's acting, A is still moving in this direction, but not because of a force, it's moving in this direction because of initial velocity. Now the force that's acting in the opposite direction is 24 sine 20, and also the frictional force. Okay, also the frictional force. So that means now if I look at the forces from A's perspective, okay, so if I use the formula forward minus backward equals to mass times acceleration, there is no forward force. The backward forces we have are plenty, so that's 24 sine 20 plus the frictional force, which I worked out earlier, that is 24, so not 24, 22.778, 22.778 equals to mass times acceleration. Now what's the mass of A? That's 2.4. What's the acceleration? Achha, quickly tell me, iski acceleration kya aayegi? Positive aayegi, negative aayegi? Quick question for you guys before I work it out. Tell me, will the acceleration be positive or negative? And also give me a reason as to why it should be whatever it is that you say it is. Negative. Why? Because it's going to slow down. It is going to slow down. So the acceleration is equals to minus 12.911. Okay. Now the final stretch. A is moving up with an initial velocity of 8.05. It will come to rest after a certain time. And the deceleration is what we have right here. The question is, what is the distance that it's going to travel? So we have the initial velocity of A, which is 0.840502. Okay. The final velocity of A is equals to 0. The acceleration not due to gravity, I was going to say due to gravity, but it's not under free fall. Okay. And the question is, what is the distance that it's going to travel? So let's work that out. So 2AS, that means 2 times minus 12.911 into S equals to 0 squared minus 0.840502 squared. ठीक हो गया? ओके, सो काफ़ी सारी वैल्यूज़ के साथ डील करना है. अच्छा, इसको हम एक काम करते हैं. 0.840. Why not under free fall? Beta, it's on a plane. Why would it be under free fall? थोड़ा common sense use कर लेते हैं. If it's on a plane, why would it be under free fall? So here we have the final distance that it travels while the string is slack, 0.027358, which means that what are we supposed to find? We're supposed to find out the total distance traveled by A. So the total distance is equal to the 1 meter that it traveled while the string was slack plus 0.02735, and now we have the total distance. Let's add 1 to it, and that is 1.0273, which means correct to 3 significant figures is equals to 1.03. ठीक है, इंतहाई किसी evil इंसान ने ये क्वेश्चन बनाया क्योंकि कोई तमीज़ की वैल्यू नहीं आ रही, कोई होल नंबर में आंसर नहीं आ रहा. So I don't know, some evil genius came up with this question. Anyway, so let's take a namaz break now. ठीक है, we will inshallah resume in like 10-20 minutes. ठीक है, फिर we'll continue till 11 inshallah. Okay, so see you guys in a while. All right, guys, welcome back. What did I miss? After you're back, can you do... what type of question is it? Tell me what type, then I'll think about it. May, June 2023, paper 4, variant 1. सर अभी ये क्वेश्चंस आराम से हो जाते हैं बट एग्ज़ाम में पैनिक होता है एंड सब भूल जाते हैं सर प्लीज़ कुछ बताएं. देखें पैनिक इसलिए होता है बिकॉज यू गाइज आर थिंकिंग, यू गाइज आर स्टार्टिंग विद द एंड इन माइंड. डोंट स्टार्ट विद द एंड इन माइंड. ब्रेक द क्वेश्चन डाउन. लाइक फॉर एग्जाम्पल अभी और करते हैं इस तरह के क्वेश्चंस, ठीक है. लेट्स डू मोर क्वेश्चंस लाइक दीज. सो what you have to do is you have to break these questions down. If you're thinking कि हम इसको directly solve कर लें या something like that, it's not possible. Okay, let's do another question. It's about pulley and strings. ठीक है, चलो कर लेते हैं. पहले एक इस तरह का सवाल और करें. Before I do that, मैं उसको ऐड कर लेता हूँ चलो, otherwise I'll forget. So you're saying May, June 2023 पेपर कौन सा है? पेपर 4 वेरिएंट 1. ओके, गुड क्वेश्चन. कर लेते हैं इसको भी. सो दिस इज़ द सेम कैटेगरी. ये क्या पता मैंने इंक्लूड किया हुआ. आई माइट हैव इंक्लूडेड दिस क्वेश्चन. या आई हैव इंक्लूडेड दिस क्वेश्चन, डोंट वरी. So we'll do it, don't worry. So this is the category when both planes are inclined. So I have included that, don't worry. Abhi pehle, first let's solve at least 2 more questions of this type before we move on. There was a question. Yeah. So this is an exact replica of the previous one. Isko bhi kar lete hain. For, yeah, because it's an exact replica, iske bajaye hum ek kaam karte hain. अच्छा इसमें energy method है, ये भी कर लेते हैं. ये वाला question कर लेते हैं. Let's do question number 13. Okay, now. Two particles P and Q of masses 2 kg and 0.25 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. Particle P is on an inclined plane at an angle of 30 degrees to the horizontal. Particle Q hangs below the pulley. 3 points A, B and C lie on a line of greater slope of the plane with AB equals to 0.8, BC equals to 1.2 respective C diagram. Alright, particle P is released from rest. From rest का मतलब that initial velocity is 0. Achha, this, just so you guys know, is also May, June 2023, paper 4, variant 2. Okay? May, June 2023, paper 4, variant 2. So, it's quite recent, I would say. The link is in description, guys. अभी तक आप लोगों को आदत नहीं हुई? खैर, I think you're here for the first time, but anyway. So, let's begin. The question says, during the motion of P from A to C, so P moves from A to C, Q does not reach the pulley. So Q does not reach the pulley. All right. The part of the plane from A to B is rough. So this is rough with coefficient of friction 0.3 between the plane and P. All right. The part of the plane from B to C is smooth. All right. Let's keep that in mind. Find the acceleration of P between A and B. Okay. So between A and B only. So first things first, let's see. A slides down the plane. Yeah. So first of all, this is the direction in which A is going to move in. So let's make a double arrow. Okay, which means that Q will move up the plane. All right. Q moves up the plane. What is the force due to which it's moving up the plane? It's moving up the plane due to tension. What is the force that's acting in the opposite direction? That is its own weight, which is 2.5 Newton. Okay. Now, what's the force due to which P slides down the plane? That is its weight component, which is parallel to the plane. ठीक हो गया? And this angle will be the same as the one that's given here, which is 30 degrees. So that means this angle will be 30 degrees. Now this will be 20 Newton. This will be 20 sine 30. Okay. And this, the component of the weight acting down the plane, will be 20 cos 30. Don't forget that since A to B, the part of the plane from A to B is rough, that means you have to deal with frictional force, which means you have to consider the normal reaction force acting in this direction. And because it's moving down the plane, that means the frictional force will be acting in the opposite direction. ठीक हो गया? Okay, now let's look at the forces starting from Q. Q simple as, so first let's look at it from Q's perspective. Achha, is it in equilibrium or something? Does the question say that it's in equilibrium? No, of course, because it's asking for acceleration, so how can it be in equilibrium? So since Q is moving up, it's moving up because of tension. The force that's acting down the plane is 2.5, and this is equal to mass times acceleration, so that means this is equal to 0.25a. Kinematics, beta, I've already done it. Okay, I've already done kinematics. Okay. Achha, a question where they have the same height. I have one question in mind. I will do that. Don't worry. Now let's talk about P. So the force due to which P slides down is its weight component. So that's 20 sine 30 minus all the forces acting in the opposite direction. So I forgot to mention tension. Tension is acting in the opposite direction. So that means minus the tension plus the frictional force equals to mass times acceleration. So ek kaam karte hain, let's just directly write this as minus tension minus frictional force so that we can straight away add and start simplifying. Minus the tension minus the frictional force equals to mass times acceleration, which means equals to 2a. Now straight away I can add these two equations, and the objective is so that t gets eliminated. So t gets eliminated. So we have minus 2.5 plus 20 sine 30. So that's equal to 7.5. Reminder that बेटा S1 मैं M1 से फारिग हो जाऊँ फिर मैं S1 भी कर लूँगा. ठीक है, परेशान ना हो आप लोग. I will do S1, don't worry. So 7.5 minus the frictional force equals to 0.45a. Okay. Now let's have a look at the frictional force. So frictional force we know is equals to mu times r. Are we given mu? Okay, we're given mu, that's 0.3. What about the normal reaction force? The normal reaction force will be the same as the component of weight, which is perpendicular to the plane. That's 20 cos 30. So that means 0.3 into 20 cos 30. Let's work this out. So the frictional force is equal to 0.3 into 20 cos 30. So we're looking at 3 under root 3. Let's keep everything in its exact form till we get to the very end. So we have 7.5 minus 3 under root 3. And while we're at it, let's divide it by 0.45. And what's that equal to? That's equal to acceleration. So 7.5 minus answer divided by 0.45. So we get the acceleration. What is that equal to? Wait a minute. 7.5 minus 3 under root 3 divided by 0.45. Oh, 0.45 nahi hai na. It's 2.25. It's 2.25. Wait, मैं कहूँ कुछ कर पड़े. Okay, 7.5 minus 3 under root 3 divided by 2.25, that's equal to 1.02. So the acceleration is equals to 1.0239. And since we're only supposed to find out the acceleration in this part, so 1.02 meter per second square is good enough. Okay, now let's have a look at the following part. Hence find the speed of P at C. Okay, the speed of P at C. Interesting. Speed of P at C. How many marks? 5 marks? Yeah, it better be 5 marks. Achha, here's what we're going to do. So first of all, let's find out the speed at B. Okay, so the first thing we have to do is we have to first find out the speed at B. We can't directly find out the speed at C, so we'll have to break it down step by step. So the initial velocity of P was equal to 0. The acceleration that we just worked out is 1.0239. 1.0239. The distance that it travels from B to from A to B. Actually, why are we considering it differently? Because from A to B the acceleration will be different. From B to C the acceleration will be different. Why? Because the plane from B to C is a smooth one. So B to C जो plane है वो smooth है. उसके लिए हमें सारी working दोबारा से करनी पड़ेगी. We'll have to figure out what the acceleration is separately. So the distance that it travels is 1 meter. Let me just double check. No, 0.8. So the distance that it travels is 0.8 meters. Now the question is, what will be its final velocity? So we have 2as equals to v square minus u square. So that means 2 times a, which is 1.0239, times s, which is 0.8, equals to v square minus 0 squared. So I'm going to use the answer key for acceleration so that I don't have to write it again and again. So I'm looking at the value of v to be equal to 1.27995 तक काफ़ी है, ठीक है? It's actually 6 meters per second. Why am I not rounding this off? Because it's not the final answer. अच्छा, उसके बाद क्या हुआ? After that, what's happened is that now particle P is on a smooth surface. Okay? Now particle P is on a smooth surface. Okay? Now since particle P is on a smooth surface, that means कि अब friction force नहीं होगी, ठीक है? Downward force होगी in the sense that there will be a force that's parallel to the plane, but there will be no frictional force. Okay? Now this particle will still move down because of the weight component, which is 20 sine 30. So it's still moving down because of 20 sine 30. There is still tension acting in the opposite direction. Okay. But there is no frictional force. Okay. There is no frictional force. So now if I look at the forces from P's perspective, it's 20 sine 30 minus t, which is equal to what? Which is equal to mass times acceleration. The mass is 2, so that means this is equal to 2a. अच्छा, 20 sine 30 को हम evaluate करके 10 लिख सकते हैं. So 10 minus t is equals to 2a. This is what it looks like from P's perspective. Now as far as Q is concerned, Q मजे में, Q को फर्क नहीं पड़ता whether it's smooth or rough. Q doesn't care. Because from Q's perspective, it's t minus 2.5 equals to mass times acceleration irrespective. So t minus 2.5 is equals to mass times acceleration. And what's the mass? The mass is 0.25 times a. So now tension gets eliminated. So we have 7.5 is equals to 2.25 a, which means a is equals to 7.5 divided by 2.25. That's equal to 10 upon 3. So 10 upon 3 meter per second square. Achha, what have we done? We have basically figured out the acceleration as particle P is traveling from B to C, which is a distance of 1.2 meters. Okay, what we have done is basically we have figured out the acceleration at which particle P is going to travel from the point B to point C, which is 1.2 meters. Now the question is, how can I calculate the speed at C? Now notice that the final velocity of the first part of the journey will now become the initial velocity of the second part of the journey. So now the initial velocity of P is equals to 1.27996. We have to find out the final velocity. Okay, so initial velocity of P is what was the final velocity when it was traveling on a rough surface, because as soon as the rough surface ends, the smooth surface starts. So the final velocity while it's traveling on the smooth surface is what we want. The distance that it's going to travel on the smooth surface is 1.2, and the acceleration is 10 upon 3, which we just worked out all over again, since we're now dealing with a different plane. Okay, so we're going to use the same formula, 2as equals to v square minus u square. So 2 into 10 upon 3 into s, which is 1.2, equals to v squared minus 1.27996, the whole thing squared. So let's work this out. So 10 upon 3 into 2 into 1.2, ठीक हो गया, plus 1.27996, the whole thing squared. Let's take the square root of the answer. So we get the velocity at P to be equal to 3.1045, which correct to three significant figures is equals to 3.10 meter per second. That's it. Maza aaya? This was fun, no? Sir, I find diagrams challenging and it hurts my brain for M1. My other chapters are fine. But because of this Newton's law of motion, beta M1 में diagrams ही diagrams हैं. So if you're struggling with diagrams, तो for what's left? So on Monday I have my further maths P1. Wow. Along with psychology. Wow. Chale, good luck. Good luck to you, Mariam. All right, now M1 mock tomorrow, inshallah. Find the time taken for P to travel from A to C. Achha, thankfully, it has made us do all the hard work, so it's not going to be that difficult, considering that we have the acceleration from A to B, the distance, so it's going to be easier for us to find out the time. Okay, so let's divide this journey down. Let's have a look at it from A to B. Okay. So from A to B, the initial velocity was equal to 0. The final velocity was 1.27996. All right. No, we're not going to have the AI checker. We're just going to do it the normal way. S is equals to 0.8. All right. And what we want is the time. So technically, we also have acceleration, so we can use the simpler formula v equals to u plus at. That's going to be easy. What was the acceleration? The acceleration was 1.0239. 1.0239. So we're going to use the formula v equals to u plus at. ठीक है, इसमें से t को subject बना लो. So it's going to be v minus u upon a. So t is equals to v, which is 1.27996 minus u, which is 0, upon a, which is 1.0239. Let me just double check all the values. Yep, that's correct. So that means the t for the first part of the journey, which is from A to B, is 1.27996 divided by 1.0239. And you get 1.25008. ठीक है, अब आगे देखते हैं. Okay, now, then when we are finding out the time that it takes to travel from B to C, remember everything's different. The initial velocity now will be the final velocity of the first part of the journey, which is 1.27996. The final velocity, the question has already made us work it out, which is 3.1045. The acceleration is 10 upon 3. बस यही एक तमीज़ की value है, बाकी सब तो अजीब values हैं. And now we're supposed to find out the value of t, and we're going to do it using the exact same formula. So 3.1045 minus 1.27996, ये भी किसी evil mastermind ने बनाया होगा, looking at the values that we're getting. So let's see what do we get. So 3.1045 minus 1.27996 divided by 10 upon 3. So we get T2 as 0.547362. Now let's add them up. Let's add these two values of t and let's see what do we get. So this plus 1.25008. So we get the final answer as 1.797. Okay, this is the total time, which means correct to three significant figures, it's going to be 1.80 seconds. Okay, don't forget to put the 0. If you don't, it's not three significant figures. And there you go. That's it. Mazaya? So whenever these kind of values come with such decimals, I start. But if you do enough questions, you will realize that it's something that's not very uncommon. Okay, if you do enough questions, you'll realize that it's not very uncommon. But yeah, I do agree that when you have a nice value, you automatically think that you're doing something right. Compared to if you don't, you start doubting yourself. Okay, now. So we'll have a mock and then I will not upload the marking scheme. I will inshallah. क्या बोलते हैं? I'll solve the mock. Simple as that. ठीक है? अच्छा ये वाला क्वेश्चन करते हैं जो आप बोल रहे थे ना, सेम हाइट और इसमें एनर्जी मेथड भी लगाना है, ठीक है. Alright, let's solve this. You're welcome, Fatma. So should I start from the back of the paper to focus more on the hard questions? Start with the easy ones. Always start with the easy ones. Get your confidence level high and approach the difficult ones with a higher level of confidence. You're likely to get it right. Okay? Yes, hopefully I will be able to cover those difficult momentum questions also, inshallah. Let's hope I find enough time. Kitna time hai? We have tomorrow, we have day after, 3rd, 4th, 5th, 6th का ना आप लोगों का पेपर. So 3 दिन है, कर लेंगे inshallah. कुछ ना कुछ कर लेंगे. We'll pull an all-nighter or something. Do you guys have an exam on Monday? If you do, let me know which one. बेटा S1 की क्या टेंशन है, S1 तो 12th को है, there's plenty of time. ठीक है, so 6th से मैं S1 start कर लूँगा, don't worry. So we'll have 6th, 7th, 8th, 9th, 10th, 11th. Yeah, 6 days, inshallah. Plenty of time. Okay, it is given that the plane is rough. Okay, you do have an exam on Monday. All right. Khair. And the particles are in limiting equilibrium. All right. Find the coefficient of the friction between B and the plane. Now, even if they are in limiting equilibrium, that still means that if they start moving, unless mentioned otherwise in the question, okay, it's the heavier particle which falls down. Okay, and that means B will start to move up. Okay. Now the question is, what's the force due to which A falls down? It falls down because of its own weight, which is 40. What's the force that's acting in the opposite direction? That's T. Now let's look at B. So the weight is acting downwards. That's 30 newtons. Here is the weight component, which is parallel to the plane, which is going to be equal to 30 sine 30. And here is the weight component, which is perpendicular to the plane. That's going to be 30 cos 30. And then don't forget that you have a normal reaction force also. Is the plane rough? Yeah, the plane is rough. So we have to take that into account. Okay. And also don't forget the force due to which it's going to move up is tension. Okay. Now let's start from A's perspective. Okay, let's start resolving forces from A's perspective. So A, chile, sif weight hai or tension hai, that's it. So that's 40 minus T is equals to 4A. That's it. Job done as far as A is concerned. Okay, now it's B where there's a lot going on. So it's moving up because of the tension. And the forces acting in the opposite direction, since the plane is rough, that means there's got to be a frictional force acting in the opposite direction and its own weight component. So that's 30 sine 30 minus the frictional force acting in the opposite direction equals to mass times acceleration, which is 3A. हाँ, I know नीचे वाला question, मैं direct तो नहीं करूँगा ना नीचे वाला question, ठीक है? पहले ये कर लेते हैं ना. अच्छा, then what happens is that T gets eliminated. And what is 40 minus 30 sine 30? What's that equal to? That's equal to 25 minus the frictional force is equals to 3A. Now let's park this on the side and let's focus on the frictional force, which is mu times R. Are we given mu? No, wait, to nikalna hai. Okay. So the frictional force is equals to mu times R, which is 30 cos 30. So mu times 30 cos 30. Okay, so this means that 25, achha, because they're in limiting equilibrium, actually, now 3A hai, now 7A hai, simply equal to 0 hai. Okay, because they are in limiting equilibrium, so it's simply equal to 0. ठीक है, तो इसको हम equal to 0 ही कर लेते हैं. सही है? Now, so 25 is equal to the frictional force. Okay. Which means that, अच्छा मैं confusion avoid करने के लिए ना यहाँ पे equal to 0 कर देता हूँ. Equals to 0, equals to 0. ठीक है? Okay, now, so 25 is equals to the frictional force, which means 25 is equals to mu times 30 cos 30, which means mu is equals to 25 divided by 30 cos 30, which is equal to 5 under root 3 over 9. Okay, now does the question say that round it off or something? No, it doesn't. But we can leave it right here. We can leave it like this, or you can write 0.96225, which correct to 3 significant figures is 0.962. ठीक है. अच्छा, ये कहाँ का सवाल है? This is from October November 2022 paper 4 variant 1. Sir, could you attempt question 4 also related to forces and its unique? Okay, I'll do that. ठीक है. पहले let's do it step by step, okay? Now, so we have the frictional force, okay? Now let's have a look at part B. A part B बड़ा interesting सवाल है. ठीक है, pay attention. It is given instead that the plane is smooth and the particles are released from rest when the difference in the vertical heights of the particle is 1 meter. So that means this is the point when they're released, and we all know what happens when they're released. A falls down, okay, and B moves up. So what happens as soon as they're released, correct? Acha. फिर उसके बाद use an energy method. So we don't have a lot of room. A lot of room for our own methods, meaning we can't use Newton's second law here. We can only use the energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. Okay, now because we have no room, we have to use the energy method. Okay. So first let's understand the distance that they need to fall before they are at the same height. So let's suppose that A falls x meters. Now if A falls x meters, what does that tell you about B? Because they're connected, ठीक है? So अगर एक x meters नीचे को आ रहा है, so दूसरा जाहिर सी बात है x meters ऊपर को जाएगा, ठीक है? We've done plenty of questions, right? When one particle falls a certain distance, the other particle rises a certain distance. So this means that particle B will rise x meters, okay? And when it does that, they will be at the same horizontal level. Okay, so when particle B rises x meters, they will be at the same horizontal level. Okay? Achha. Ab the question is, how do we find out the value of x? So pay attention. Let's first figure out the distance that B rises vertically. Okay? Let's find out the change in height of B, the height that B gains. Okay, I'm not talking about the distance that it moves up the plane. I'm talking about the height that it gains. Okay, so I repeat. A falls x meters, let's assume, which means that B will rise x meters. Okay, so I repeat. A x meters नीचे को आया, A falls x meters, and consequently, because they're connected, B will move x meters up the plane. But the question is, what's the change in height? Okay, what is the change in height of B? So for that, we are going to draw a separate triangle. Okay, let's draw it separately. It's going to be easy for us to work it out. अच्छा, ये कुछ ज़्यादा ही बड़ा बन गया. इसको थोड़ा छोटा कर लेते हैं. इतना कर लेते हैं, काफ़ी है. ठीक है. Now this angle is 30 degrees. This is x. Okay. What we want to find out is the change in height. So height किसके बराबर होगा? Height will be equal to x sine 30. Okay, what's the height equal to? Height is equal to x sine 30. Now, here's something worth paying attention to. X sine 30 is the distance that B rises. Okay, is basically the height that B gains. X is basically the height that A loses. Okay. And what will be these two heights combined? What will be these two distances combined? These two combined will be equal to 1. Okay. So x plus x sine 30 is equals to 1. All right. So x plus x sine 30 is equal to the distance they were apart initially, which is equal to 1. So that means x is equals to 1 plus sine 30 is 0.5. You can use your calculator to work it out, which is equal to 1. So that means x is equals to 1 divided by 1.5, which is equal to 2/3 meters. ठीक है, ये बहुत important है. Now let's see what's next. Now what is the energy method? The energy method is total work done equals to change in potential energy plus change in kinetic energy. Change in potential energy plus change in kinetic energy. Okay. Acha, what does it mean when it says total work done? Total work done basically means work done by all the forces that are acting in the direction the object is moving minus work done by all the forces that are acting against the direction the object is moving. Okay. Now, is there any force acting in the direction the object is moving in? I'm talking about an external force. No, there isn't. Okay, I'm not talking about the weight. I'm talking about any external force. Okay, there isn't any. A नीचे को move कर रहा है, B ऊपर को move कर रहा है. ठीक है? Now you might think, okay, what about tension? Don't we consider tension? Considering that for A, since A is moving down and B is moving up, tension is a force which is acting in the opposite direction. You might think, why don't we consider tension? Well, the thing is, even if we do consider tension, tension will just cancel out each other. Okay, these two tensions will cancel out each other. If you're thinking we should consider tension, since tension for A is a force that's acting in the opposite direction, and tension for B is a force that's acting in the direction the object is moving in, we're not going to consider it because it gets cancelled. Okay? Okay, now, so that means the total work done is 0. So do not forget that the plane is rough. Okay, and if the plane is rough, that means there's got to be frictional force to consider. So frictional force is something to be considered, and we need to find out the work done against motion. Okay, so what is the frictional force? I think we worked out the frictional force earlier. Yeah, frictional force is 25. It's smooth. Oh, okay, it's smooth. All right, I didn't realize that it's smooth. ठीक है, चलो ये तो और भी आसान हो गया. So that means the total work done is 0. That's it. Now, what about the change in potential energy? Now, A is a particle that loses potential energy because it falls down. All right. So what is the potential energy that it loses? It's going to be mgh. So 4 into 10 into 2 upon 3. Okay, so this is for A. It loses potential energy, so we're going to put a minus sign. Okay, so this is for A. So A loses potential energy. B, on the other hand, is an object that gains potential energy. Okay, and what is the potential energy that it gains? Let's work it out. M is 3 into 10 into the height, which is 2 upon 3 sine 30. Okay, so this is B's gain in potential energy. How do we know there is no work done? Because there is no force. There is no resistive force. There is no driving force. That's why there is no work done. मुझे बताओ, is there a force that's pulling this object? No. Is there a force that's pulling this object? No, there isn't. Now you might say that there is tension, but for B, tension is acting in one direction. For A, tension is acting in the opposite direction. And since they're both moving the same distance, they will cancel. The work done by these two forces will cancel out. Okay? That is why there is no work done. Okay? Now, what about the kinetic energy? Now, please understand that since these objects are connected, they will both move at the same speed. Okay? Since, yes, tension can be considered not as a form of driving force, but it can be considered as a force that's acting in the direction the object is moving in. ठीक है? और driving force के तौर पे भी हम tension देखो, but driving force is normally force that is produced by an engine. Maybe someone is pushing it, or maybe there's a cyclist or something like that. Then you consider, that is what you consider a driving force. Okay? Now, change in kinetic energy will be half into m. Now, because they're connected, we will take the combined mass. So that's 7 into the final velocity squared minus the initial velocity squared. And the initial velocity was 0. Why? Because they were basically released from rest. So 0 is equals to, now let's work this out step by step. 4 into 10 into 2 upon 3, that's 80 upon 3 with a minus sign. Plus 3 into 10 into 2 upon 3 sine 30. So that's 10. Plus 7 upon 2 v square. Yeah, instead of writing 7 upon 2, let's write 3.5 v square. Okay. Now, 80 upon 3 minus 10, that's 50 upon 3. So that means 3.5 v square equals to 50 upon 3. Okay, now 50 upon 3 divided by 3.5. So we get v square to be equal to 100 upon 21. Now what are we going to do at this point? We're going to take the square root on both sides. And if you do take the square root on both sides, you get the velocity to be equal to 2.18217, which means, correct to 3 significant figures, it's 2.18 meters per second. Okay. How do you know the distances will add to 1? Because they're going to be at the same height. That's what the question says. If they're at the same height, that means the height that A loses plus the height that B gains will be equal to 1, since this is 1. Okay. All right. Now I'll give you guys a summary of this. Since it's a tricky question, make summary there though. Now, first of all, for both of them to be at the same height, A has to come down a certain distance and B has to come up a certain distance. So we said, okay, let's assume that A comes down x meters, which means that B will go up x meters. So if A comes down x meters and B goes up x meters, B travels x meters up the plane, which means the change in height is something that we will have to calculate using basic trigonometry, which is x sine 30. Now, A's change in height plus B's change in height equals to 1 meter, because that is how far apart they were initially. So that way we end up finding out the value of x. Okay. No, beta, I don't do S2. Okay. Okay. Now, अब senior, since we're only supposed to use the energy method, we use the energy method, which is total work done equals to change in potential energy plus change in kinetic energy. Total work done basically means all the work done by the driving force minus all the work done by forces acting in the opposite direction. Now, why is there no driving force? And why are we not considering the work done by tension? Because tension is basically acting in the opposite direction for A, is acting in one direction for A and in the opposite direction for B. So they'll both cancel out each other. So that's why we're not considering the work done by tension. Why are we not considering by work done by any resistive force? Because there is no friction. Why? Because the plane is smooth. Okay. Change in potential energy, we'll have to work out one by one. We'll have to first find out the loss in potential energy of A. That's this right here. Okay, and then we'll have to add the gain in potential energy by B, which is this right here. And for that, you'll have to calculate the height, which is x sine 30. Or what you can do is, since you know that x is equals to 2 upon 3, this will be equal to 1 upon 3, since you can subtract 2 upon 3 from 1. And then the kinetic energy can be combined because they're both connected. Okay, so why have we combined? Because they are both are connected. So whatever velocity one particle moves in, the other particle will also move in the same, will also move at the same velocity. Okay? If friction was there, then you would consider friction over here. Okay, you would do 0, work done by driving force is 0, minus the frictional force multiplied by the distance. ठीक है, अगर friction force होता तो. And what distance? Because friction would only be acting on B, so we would take frictional force into x. Let me see if I can do a question where we have to use energy method to calculate, where we have to use energy method and there is friction also. Let me see. Okay, first let's do questions where you have two objects and they're both of them on an inclined plane. फिर हम ये वाले सवाल करेंगे, डबल पुली वाले. Okay, let's do this. Now, it is given that theta is equals to 60, the plane BC is rough, and the coefficient of friction between Q and the plane BC is 0.7. All right. The particles are released from rest. Determine whether the particles move. Okay, let's do that. Acha, what about the plane AB? What do we know about the plane AB? Let's read the entire question. Two particles P and Q of mass 0.2 kg and 0.1 kg are attached to the ends. Achha, this is May June 2023, paper 4, variant 1. Okay, this is May June 2023, paper 4, variant 1. Yeah. The string passes over a fixed smooth pulley at B, which is attached to two inclined planes. Particle P lies on a smooth plane AB, alright, which is inclined at an angle 60 degrees to the horizontal, alright. Particle Q lies on a plane BC, which is inclined at an angle of theta degrees to the horizontal. The string is taut and the particles can move on lines of greatest slope of the two planes. It is given that theta is equals to 60, the plane BC is rough, and we're given the coefficient of friction, which is 0.7. Now what we're supposed to do is we're supposed to find out whether they move or not. Okay. So let's see. First things first, irrespective, we'll have to break down the forces. अच्छा, अब क्योंकि ये डायग्राम इतना steep बना हुआ है कि it's practically impossible to break the forces down on this particle, so I'm going to draw it separately. ठीक है? So इसको हम ज़रा separately बनाते हैं. Now, as far as particle P is concerned, the weight is acting downwards. The component of the weight perpendicular to the plane. Then we have the component of the weight that is parallel to the plane. ठीक है? All right. Now. Okay. So this is 90 degrees. The weight is 2 Newton. ठीक है? And this is 60 degrees, which means the component of the weight parallel to the plane is 2 sine 60. And this is the component which is acting, this is the component which is acting down the plane. That's going to be equal to 2 cos 60. And because this part of the plane is smooth, then there is nothing to worry about the normal reaction force. Okay, but let's write it anyway. Maybe in a different part they might change it or something. Okay, now let's talk about Q. So Q is on an even steeper plane, okay, where theta is equals to 60 degrees. Actually, no, it's the same. It's not steeper, it's the same. So let's break down the forces that are, let's break down the weight component. Okay. So the weight is acting vertically downwards. Then we have the component of the weight, which is perpendicular to the plane. Then the component of weight, which is parallel to the plane. What is the mass of Q? That's 0.1. So that means the weight is 1 Newton. And then we have 1 sine 60 or simply sine 60. And then we have cos 60. Since this is equal to 60 degrees. Here we do have to consider the normal reaction force. R. And we have to determine whether the particles move or not. Okay. Now. Sure. Okay. Now. So if I look at, let's assume that they do move. Okay. And if they do move, they will basically, P will move down and Q will move up. Okay. Achha. Now, what's the force that's acting down the plane? If I look at P, what's the force that's acting down the plane? The force that's acting down the plane is equal to, the force that's acting down the plane is equal to 2 sine 60. Okay. Minus T equals to mass times acceleration. Okay. Equals to mass times acceleration, which means 0.2a. Okay, now, then let's look at the forces from Q's perspective. Now, because Q is on a rough surface, so we have to deal with friction also. So here we have the frictional force. Okay. Now, what's the force due to which it will move up? If it moves, it will move up due to tension. Okay, tension is acting in the opposite direction over here. So that means T minus the weight component, which is sine 60, also minus the frictional force. Okay, and what's the frictional force? We'll work it out in a minute. Equals to mass times acceleration, which means 0.1a. Okay. So the frictional force is equals to mu times R. That means the frictional force is equals to 0.7 times R, and we worked out R is equals to cos 60. So that means we can calculate the frictional force. Okay, why is angle 60? Because it says so in the question. Read the question. 0.7 into cos 60, what's that equal to? That's equal to 0.35. Okay, now, so as I add these two equations, t gets eliminated. Okay, so this is what we're looking at. We're looking at 2 sine 60 minus sine 60 minus the frictional force, which is 0.35, equals to 0.3a. Won't the weight be cos 60? It is cos 60. It is cos 60. ठीक है. Now, अब अगर इसका आंसर नेगेटिव आएगा, 2 sin 60 minus sin 60, that means they don't move, minus 0.35. Okay. If the answer turns out to be negative, that means the particles don't move, but it does not turn out to be negative. It does not turn out to be negative, that means they do move. So this turns out to be 0.5160. ठीक है. This turns out to be 0.5160. 25 equals to 3a. Okay, now because this force 0.516025 is greater than 0, okay, therefore the particles move. Now we're not supposed to find out the acceleration, okay, so no need to go ahead and find out the acceleration. You're just supposed to find out whether they move or not. So you can see that the forward force is more than the force that's acting in the opposite direction, therefore they do move. Okay. So I repeat. We just, okay, forget what the question is saying for a second. Okay? You're supposed to find out whether the particles move or not. Okay? The working that we're going to do is not going to be any different compared to all the other questions. So you just look at the forces from P's perspective. So you know P, if it moves down, it will move down due to its own weight component. So that is 2 sine 60. The force acting in the opposite direction is tension. This is equal to mass times acceleration. You do the exact same thing for Q. Okay? And then you add them up exactly like you would do in a normal question. Now, if let's suppose this turned out to be 0 or maybe this turned out to be negative. So that means they don't move because it's not possible for a system which is already at rest to decelerate. That does not make sense. Okay? But when we simplify, we do notice that the resultant force is greater than 0. If the resultant force is greater than 0, that means they will move, they will accelerate. Now, we're not supposed to find out the acceleration, but the idea is to figure out whether the resultant force is greater than, no, not even limiting equilibrium. It's greater than 0, that means they will move. Simple as that. Okay? Not limiting equilibrium. If there is acceleration, how does it not move? They do move. When did I say they don't move? They do move. Okay? If the acceleration is positive, how will they move? The acceleration is positive, that means that the speed is going to increase. And the speed agar increase hogi, that means they're going to move. Okay? If the speed is positive, what is that? If the acceleration is positive, acceleration is positive means that the speed is going to increase. And what does that mean? That means they move. Achha, I said they don't move? Okay, no. I said they move. I've written that therefore the particles move. Okay, maybe I said they don't, but anyway, there you go. If A is less than 0, that means they do not move. Okay, A is less than 0 ka matlab, it does not make sense. Why? Because it's not that they're moving to begin with, that they're now slowing down. They're not moving to begin with, and if acceleration is less than 0, that means it's meaningless. Therefore, they do not move. The acceleration is less than 0 means that the resultant force is less than 0. If the resultant force is less than 0, that means they're not going to move. Acha, he said he thought. Okay, thought you said it does not move. Acha, khair ho gayi, koi baat nahi. Anyway, part B. It is given instead that the plane BC is smooth. All right. The particles are released from rest, and in the subsequent motion, the tension in the string is √3 minus 1 Newton. All right. Find the magnitude of acceleration of P as it moves on the plane and find the value of theta. All right. This should be fun. Isko karte hain erase. Let's take a nice and clean screenshot of this. Okay, now so अब सब कुछ smooth है, tension भी आ गई हमारे पास, that's √3 minus 1, and release from rest, subsequent motion and the tension. Acha, if they're released from rest, that means they're going to move in this direction unless mentioned otherwise. Okay, so it's always the heavier particle that comes down and the lighter particle goes up. Okay, okay, now let's look at the forces from P's perspective. Achha, P ko fark nahi padta because P to already ek smooth surface pe hai. So as far as P is concerned, the force that due to which it's moving down the plane was equal to 2 sine 60. So 2 sine 60 minus the tension. So we've got to be careful over here. That's under √3 minus 1. Okay. वैसे टेंशन ने तो कैंसिल ही हो जाना है, तो लेट्स कीप इट एज इट इज़. ठीक है, टेंशन ने तो कैंसिल ही हो जाना है, लेट्स कीप इट एज इट इज़. इक्वल्स टू 0.2 है. ऑलराइट, नाउ लेट्स लुक एट द फोर्सेस फ्रॉम Q's perspective. So Q is moving up because of the tension, ठीक है, minus the forces that are acting in the opposite direction, and that will no longer be friction since the plane BC is also smooth. That will simply be its own weight component, which is 1 sine 60, which is simply sine 60 equals to 0.1 A. ठीक हो गया? Okay, now, so 2 sine 60 plus minus sine 60 is simply equal to sine 60, all right? And if this is equal to sine 60, this means that this is equal to 0.3A. And what is A equal to? Let's work it out. Sine 60 sine theta होगा? Oh, okay. Of course. Theta तो हमें different हो गया ना? Okay, sorry, my bad. So sine theta. अच्छा, वैसे आई थिंक कि हमें टेंशन को कंसिडर करना चाहिए था. वी शुड हैव कंसिडर्ड टेंशन. चलो देखते हैं, लेट्स कैरी ऑन, फिर विल सी. सो वी हैव 2 sin 60 minus sine theta, which is equal to 0.3A. अच्छा, अब the problem is that we can't solve this. Okay, no problem. What we can do is, if I just look at the forces from P's perspective, ठीक है, हमें combine करने की ज़रूरत नहीं थी. Yeah, okay. So if I just look at the forces from P's perspective, that is enough to help me find out the acceleration. Okay, so 2 sin 60 minus the tension, which is under √3 minus 1. So मैं सही कर रहा था. Under √3 minus 1 is equals to 0.2A. So this will give us the value of acceleration directly. Because I thought that theta, I didn't realize that theta अब change हो गया, and we're actually supposed to find out the value of theta. If we were given the value of theta, then we could have just carried on. Okay? But since theta is different, so we can't do that. So 2 sin 60 is under √3. So under √3 minus under √3, then minus will become plus. So under √3 minus under √3, okay, plus 1 is equals to 0.2A. So this cancels out. A is equals to 1 divided by 0.2, which is simply equal to 5 meter per second square. Okay. Why is it sine 60 for Q? No, it's not sine 60. Okay, that's the error. It's not sine 60. Okay. It's not sine 60. That is the error. Okay. Achha. Now that we have the value of A, it's up to us that we can plug it in this equation, or we can plug it in the combined equation. Achha, you know what? Let me do this question again. वो शुरू में confusion हो गई ना, उसकी वजह से सारा मज़ा ख़राब हो गया. Let's do it again. So our main focus right now is on P. Okay, so let's just focus on P. So if I look at the forces from P's perspective, P is moving down the plane because of the weight component, which is equal to 2 sine 60, and we will get rid of the tension since it's acting in the opposite direction is equals to 0.2a. Now we're already given the tension, so that means 2 sine 60 minus t, which is under root 3 minus 1. So t sine 60 minus under root 3 minus 1 is equals to 0.2a. We will get the acceleration with the help of this equation. So 2 sine 60 is equals to under root 3 minus under root 3. Minus minus becomes plus. So plus 1 equals to 0.2a. This cancels. A is equals to 1 divided by 0.2, which is equal to 5 meter per second square. Okay. तो ये आ गई मेरे पास the acceleration of P, which is obviously going to be the same as the acceleration of Q. Now let's look at the forces from Q's perspective. So Q is moving up because of the tension. And now that since plane BC is also smooth, that means the only force that's acting in the opposite direction is its own weight component, which is parallel to the plane, which is going to be equal to, sorry, once again, मैंने 60 कर दिया. ठीक है, it's not 60. ठीक है, it's actually 30. So that's sine. It's actually theta, so that's sine theta. So t minus sine theta is equals to mass times acceleration, which is 0.1a. So we already know that t is under root 3 minus 1 minus sine theta is equals to 0.1a. So a is 5. So this means that this will now become 0.5. So let's make sine theta the subject. If I make sine theta the subject, sine theta will be equal to under root 3 minus 1 minus 0.5, which means sine theta is equals to under root 3 minus 1.5. And now you can find out theta by taking sine inverse of under root 3 minus 1.5. Let's take sine inverse of the answer, which is equal to 13.417. 13.417, which means theta is equals to 13.4 degrees. There we go. Will you do part 2 of this? Wasn't I already solving part 2 of this? I was doing part 2 of this anyway. Okay. Now let's do another question. Okay, now, say you did a mistake at A. I did. What mistake? बताओ, क्या mistake? He wrote 3A instead of 0.3A. Oh, okay. Khair, irrespective. It's not a costly mistake. But yeah, you're right. It is wrong. It's supposed to be 0.3. So thank you for pointing that out. So tension is moving up in both sides. So how does one tension sign is negative? No. See, it's not about whether it's moving up or down. It's about the direction in which the object is moving in. If this object is moving down, so we will take the forward force that is acting in the direction the object is moving in. That is its weight component. Since this object is moving up, so the force that's acting in the direction the object is moving in, that is going to be considered the forward force, which is tension in this case. Okay. Achha, 3 particles karne se pehle, I was thinking that maybe we get a good grip on this before we move on to 3 particles. Let's do this also. Okay. Let's do this question. So work energy power, मैं इंशाल्लाह work energy power मैं सोच रहा हूँ कि question number 3 of this type. 5, 4. This. ये थोड़े पुराने सवाल हो गए हैं. It's best that we do recent ones. That is why. For the next one, अच्छा, first let's do a practice of this. ये करना है, अच्छा सवाल है. वैसे इतना भी कोई यूनिक नहीं है. It's the same concept. Actually, let's do this question. This is a nice question. So this is from May-June 2022, paper 4, variant 3. ठीक हो गया. इसका पहला part तो pretty straightforward. The first part is pretty straightforward. It's the following part that's tricky. Okay? Okay, now. Two particles P and Q of masses 0.3 kg and 0.2 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley at B, which is attached to two inclined planes. P lies on a smooth plane AB, which is inclined 60 degrees to the horizontal. Q lies on a plane BC, which is inclined at 30 degrees to the horizontal. The string is taut and the particles can move on lines of greatest slope of the two planes. All right. It is given that the plane BC is smooth and the particles are released from rest. Actually, notice that in this part, we're supposed to take the plane BC as smooth, but throughout the plane AB is going to remain smooth. ठीक है, ये कंडीशन हो सकते हैं चेंज होती रहे. इनफैक्ट फॉलोइंग पार्ट में आई एम प्रीटी श्योर इट्स गोइंग टू चेंज. ठीक हो गया. Okay, yeah, we're doing momentum also. Okay, we'll do momentum and work energy power, so don't worry about it. Find the tension in the string and the magnitude of the acceleration of the particles. All right. M1 का मॉक कल ले रहे हैं और कल मैं सोच रहा हूँ साथ में एक वर्क एनर्जी पावर की भी स्ट्रीम रख लूँ. Okay, I don't know how I'll manage, but we'll manage inshallah. Okay. So अभी ये करते हैं. So let's look at P. Let's start breaking down the forces that are acting on P. So we have its weight acting downwards. Then we have the component which is acting parallel to the plane, which will be equal to 3 sine 60. So this is 60 degrees. So this will be equal to 3 sine 60. And this force will be equal to 3 cos 60. Okay. Now, let's look at Q. So this is the component perpendicular to the plane. This is the component parallel to the plane. This is 30 degrees, which means this is 2. So this will be equal to 2 sine 30. And this will be equal to 2 cos 30. And in both cases, we forgot to consider the normal reaction force, which we don't have to right now, but we will have to later on. Why do we not have to consider it right now? Because they're both smooth planes. Okay? Now, the rule is that the heavier particle comes down. So P is the heavier particle, P will come down. So all the forces acting in the direction that it's going to move in will be considered as the forward forces. And come to think of it, B भी उसी direction में ही move करेगा. ठीक है. So there is T here and there is T here. So ये भी इसी direction को move करेगा. ठीक है. Okay, now let's look at the forces from P's perspective. So the force due to which it moves down will be 3 sine 60. The force that's acting in the opposite direction is tension. Because the plane is smooth, there is no friction to deal with, and this is equal to 0.3 A. Now, let's look at the forces from Q's perspective. From Q's perspective, tension becomes the forward force since it's acting in the direction that it's going to move. The weight also becomes the forward force. Okay? Because weight is also acting down the planes, the weight also becomes the forward force, which is 2 sine 30. And there is no force that's acting in the opposite direction because the plane is smooth, so there's no friction, equals to 0.2A. Now, as I add them, tension gets eliminated, not by coincidence, but by design. So we have 3 sine 60 plus 2 sine 30, which is going to be equal to 1, equals to 0.5A. Okay? And now let's find out the value of A. A is equals to 3 sine 60 plus 1 divided by 0.5. What's that equal to? 3 sine 60, bracket close, plus 1 divided by 0.5. So we're looking at the acceleration to be 7.196, which is equal to 7.20. 7.19615, which means that the acceleration is equals to 7.20 meter per second square. ठीक हो गया? Okay, now what about the tension? Are we supposed to find out the tension? Yes. Achha, how can we find out the tension? We can use any equation actually. Let's use 3 sine 60 minus t. Actually, ये equation अच्छी नहीं है इसमें. Sine 60 भी जो है ना, वो irrational number होगा. Let's use the second one. T plus 2 sine 30 equals to 0.2a. So t is equals to 0.2 into a, for which we're not going to use the rounded off value. We're going to use the pre-rounded off value, minus 2 sine 30, which is simply equal to 1, since sine 30 is half. So let's find out the value of t. So this into 0.2 minus 1. So t is equals to 0.4392. T is equals to 0.4392, which correct to three significant figures is equal to 0.439 Newton. So tension bhi aa gayi, acceleration bhi aa gaya. A good idea is to make a box around your answer so that it's easy for the examiner to identify it. Okay, now all right. Part B. It is given instead that the plane BC is rough. A force of magnitude 3 newtons is applied directly to Q up the plane along the line of greatest slope of the plane. That basically means that it's parallel to the plane. Okay. Now, find the least value of the coefficient of friction between Q and the plane BC for which the particle remains at rest. So least value. Okay, you want to find out the least value for which the particle remains at rest. Shouldn't it be t minus 2 sine 30? Now, why would it be minus 6? That's the thing. Because the weight component is also acting in the direction the object is moving. And that is what makes this question slightly unique. Isme the weight component, both particles are sliding down the plane. Because the plane is such that they're both inclined. So that is why both of them are sliding down the plane. That is why we're not going to subtract the weight component. We're actually going to add in both the cases. Okay, now. So here we are. So first of all, the question says, okay, find the magnitude of force 3 Newton is applied to Q directly up the plane. So that means there is a force of 3 Newtons which is acting in this direction. ठीक हो गया? Okay, now. So now if I look at P, so nothing has changed as far as P is concerned. So for P, things are pretty straightforward. So P के बारे में अगर हम बात करें, so wait a minute. P is in equilibrium. Yep, that's correct. So for P, the only force that's acting down the plane, let's actually just use this equation right here. Sorry. So for P, nothing has changed. So that means we can still use the old equation, except for the fact that it is now at rest. So if it's at rest, that means it's equal to 0. Okay. So what is T equal to? T is equals to 3 sine 60, which means it's equal to 2.598. So T is equals to 3 sine 60, which means T is equals to 2.59807, or we'll see if we can keep it in its exact terms. But for Q, things are different. So for Q, the plane is now rough. That means we have to consider friction. So what is theta? Theta is still 30. That's nice. That means this will be equal to 2 sine 30. That's acting down the plane. Okay, weight is also acting down. This will be equal to 2 cos 30. And now that the plane is rough, that means we also have to take into account the normal reaction force. Okay, now, once again, हाँ मैं इसको exact form ही use करूँगा. ठीक है? So when I'm using it for the following part, I will use the exact form, which is either I'll use the answer key or I'll use the exact form, which is 3 under root 3 upon 2. Okay, so that I don't end up doing premature approximation. Okay. Now, if I look at the forces from Q's perspective, it's the tension that's acting in this direction. Okay. Now, let's assume that if it moves, it will move in this direction, obviously. If it moves, it will move in this direction. Okay. Okay, now, you can also do it the other way around. Does not make a difference. Okay. अच्छा सवाल क्या कह रहा है? Find the least value of the coefficient of friction between Q and the plane BC for which the particle remains at rest. Okay, we're supposed to find out the least value. Okay, let me think. So for least value, so tension, and if it's moving in this direction, that means the frictional force will be acting in this direction. All right. Now, so tension plus the weight component, which is equal to 2 sine 30. Tension plus the weight component, which is equal to 2 sine 30. Okay, these are the forces that are acting in the direction the object is moving in. Do we need to consider the inequality? Not really, because it says it's not moving, right? So no need to consider the inequality. You can just equate it to 0. Okay. So T plus 2 sine 30 minus all the forces that are acting in the opposite direction, which is the frictional force and the 3 Newton force, that's equal to 0. Okay. So let's find out the frictional force. So don't forget that tension is equals to 3 under root 3 upon 2. Okay. Plus 2 sine 30, which is simply going to be equal to 1, minus 3 is equals to the frictional force. So what's the frictional force equal to? The frictional force is equals to 3 under root 3. I'm keeping everything in its exact form, upon 2 minus 2. Now what is the frictional force equal to? Frictional force is equals to mu times r. What is r? R is equals to 2 cos 30. Okay, so that means mu times 2 cos 30 is equals to 3 under root 3 upon 2 minus 2. Okay, now let's find out the value of mu. Let's see what we get. So we know that 3 under root 3 upon 2 minus 2 divided by 2 cos 30. So we get the value of mu, which is equal to 0.345. 0.345, and that's your answer. Okay, now. So how do we know that the direction of motion question said least value of coefficient of friction doesn't mean that 3 Newton force will be greater than friction? Okay, now if your question is, okay, how do we know the direction of motion? ठीक है, तो मैं उसका जवाब दे देता हूँ. सही है. अब let's assume the opposite scenario. Okay, let's assume the opposite scenario, which is that what if, ठीक है, इसको साइड पे कर लेते हैं. Okay, how do we know the direction? How do we know the direction that it's moving in? Okay, how do we know the direction? Whoops, this is not what I copied. I copied was this. If I consider the opposite direction, let's see what happens. In that case, friction जो होगा ना आपका वो least नहीं होगा. It will increase. Okay. So if let's suppose we assume that the 3 Newton force is enough to pull this particle up the plane, okay, let's assume that the 3 Newton force is enough to change the direction in which the object is going to slide in. Notice what happens to the frictional force. Okay. Okay. Now, in both cases, they're not actually sliding. Okay. In both cases, they're not actually sliding. We're just assuming a direction so that we know which force to consider as the forward force, which force to consider as the negative, as the backward force. Okay, so if it's moving in this direction, that means the frictional force will be acting in this direction along with the weight component. Okay, along with the weight component. Which will be equal to 2 sine 30. So we will have 3 minus the tension minus 2 sine 30. Okay? And then minus the frictional force, which is equal to, and this will be equal to 0. ठीक है? अच्छा, सवाल ने हमसे क्या बोला है? सवाल ने हमसे बोला है to find out the least possible value. अच्छा, if you work this out, let's work this out. If we work this out, let's see what do we get. So we get 3 minus t. Achha, have you worked out the value of t? Yes. So we get 3 minus 3 under root 3 upon 2 minus 1 equals to the frictional force. Achha. So in this case, the frictional force becomes 2 minus 3 under root 3 upon 2. ठीक है? So 2 minus 3 under root 3 upon 2. इससे क्या हो रहा है? इससे the value that we're getting is negative, which means it's not possible. Okay, the value that we're getting is negative, which means it's not possible. So it's not possible that the frictional force is acting in this direction. ठीक है? Friction तो same ही रहेगी ना? Beta, the last stream that you're talking about, usme, I'm pretty sure the question was structured in a way that we considered it an inequality. Maybe it said at least, or maybe it said greatest, or something like that. ठीक है? That is why it has to do with the structure of the question. Okay, so it's not possible कि ये 3 Newton force की वजह से the particle starts moving up the plane. Okay, because the forces that are acting in the opposite direction will still be greater, and that will result to a negative resultant force. Okay, why is the forward force here? Because we're assuming that, let's say, these forces are enough to make this particle move in this direction, which they're not, because the answer that you get is negative, so this is just not possible. ठीक है? इतनी तो आपके पास forward force ही नहीं है जितनी आपके पास friction force आ गई. Okay. All right. Now, अच्छा, अब एक काम करते हैं. आई थिंक आज के लिए हम इसको यहीं पे रखते हैं. अच्छा, और एक चीज़ और याद रखो, द स्टैंडर्ड रूल इज़ irrespective whether it's rough or smooth, the standard rule is that it always slides in the direction of the heavier particle unless mentioned otherwise in the question. Okay, unless mentioned otherwise in the question. ठीक है? Okay, so आज हम यहीं तक रखते हैं. लेट्स डू अनदर राउंड ऑफ दिस. ठीक है, इसका एक और राउंड रखते हैं. Let's do another round of this inshallah tomorrow, so that we can do these annoying questions where you have 3 particles or 2 pulleys, like for example this one and this one and this one. ठीक है? So इसका एक और राउंड रखेंगे कल. And then day after tomorrow, inshallah, we will do, and tomorrow we'll have another mock also, ठीक है? And then we'll do work, energy, power and momentum. ठीक है? So एक लंबी stream करेंगे which includes work, energy, power and momentum, inshallah. ठीक है? So I'll stop here. I'll see you guys inshallah in the next class, in the next stream. So take care fellas. Allah Hafiz.